Welcome back to Chem Talk, where we always try to make chemistry just click for you.
That's right.
And today, we're diving into 6,3 ions. A quick refresher,
A quick refresh.
which is perfect if you're,
Yes,
just starting your chemistry journey
absolutely.
in high school,
Most definitely.
like 10th grade,
Yeah.
when you first
Can you first see?
see chemistry.
Uh-huh.
So we're going to, try to break down ions in a way that's clear and concise,
Yeah.
and hopefully even, a little fun.
A little bit fun.
Because, let's face it, chemistry can be a bit intimidating
It can be.
at first, right?
Yeah.
But trust me, once you understand the basics,
Uh-huh.
it's like unlocking a whole new way of seeing the world.
Absolutely. And ions are a perfect example. They might sound complicated,
They do.
but they're actually
Yeah.
key players in so many everyday phenomena.
Speaking of everyday phenomena,
Yeah.
has you ever seen the Northern Lights?
The Northern Lights. Oh, yes.
Those,
Beautiful.
shimmering curtains of green and purple
Yes.
dancing across the night sky.
Absolutely breathtaking.
So guess what?
What?
Those dazzling lights are actually caused by ions
Real.
interacting with the Earth's magnetic field.
That's incredible.
It's pretty cool, right?
Yeah.
So these tiny charged particles zipping around high above us
Yeah.
create one of nature's most spectacular light shows.
I would agree with that,
So clearly ions are worth getting to know.
for sure.
But where do we even begin?
Well, let's start with the basics. Atoms.
Okay,
Everything around us is made up of atoms,
right.
and each atom has a nucleus at its center.
With protons and neutrons
Exactly.
packed in there.
Protons have a positive charge,
Uh-huh.
and neutrons have no charge at all.
They're neutral.
Exactly.
And then, buzzing around the nucleus, we've got
The electrons.
electrons.
Yeah, tiny particles with a negative charge.
Okay, so we've got our protons, neutrons, and electrons.
Yeah.
Yeah, but how do we get from these basic building blocks to something as cool as the Northern Lights?
That is a great question. And that's where ions come in.
Okay.
An ion is simply an atom that has gained or lost electrons.
Okay.
Think of it like this. An atom wants to have a perfectly balanced number of protons and electrons.
Okay.
It's like having an equal number of pluses and minuses.
So it's like a perfectly balanced equation.
Yes,
Everything is nice and neutral.
exactly. But sometimes an atom might lose or gain an electron,
Uh-huh.
throwing things out of whack.
Okay.
If an atom loses an electron, it suddenly has more positive charges.
Right, because it lost a negative.
And negative charges, electrons.
So it becomes positively charged overall.
You got it. And we call that a cation. Now, if an atom gains an electron, it ends up with more negative charges than positive charges.
Okay, so it becomes negatively charged.
Exactly. And we call that an anion.
An anion. Okay.
Think A for add, and anion has added an electron.
Okay, I'm starting to see the picture here.
Good.
So these ions, these charged atoms, are what create those amazing light shows in the sky.
They are part of that process, yeah.
But how does losing or gaining a tiny electron make such a big difference?
Well, that change in charge makes ions very reactive. They're constantly looking for other ions with an opposite charge to balance things out.
Okay, so it's like a game of atomic matchmaking. They're looking for their perfect match. Positive attracts negative.
You could say that. And these interactions between ions are what drive a lot of the chemistry happening around us.
Okay, this is starting to make sense. But how do atoms actually lose or gain electrons in the first place?
Another good question.
Do they just pump into each other and swap electrons like trading cards?
Well, it's not quite that simple.
Okay.
Atoms can become ions in a couple of ways. One way is through exposure to high levels of energy,
Okay.
like radiation.
Oh, okay.
Think of it like a powerful blast that can knock an electron loose.
So it's like a microscopic game of atomic dodgeball.
I like that. Another common way is through electron transfer between atoms.
Okay.
Let's imagine two atoms hanging out. One with an extra electron it doesn't really need,
Okay.
and another that's desperately seeking one more electron to complete its outer shell.
Oh, so they strike a deal, like an atomic trade agreement.
Precisely. One atom donates its extra electron to the other,
Okay.
and in the process, they both become ions, one positive and one negative.
So it's like a win-win situation.
What-
They both get what they need and they become ions in the process.
Exactly.
But why is having a complete outer shell so important for an atom? What's the big deal?
Well, atoms are most stable when their outermost electron shell is full.
Okay.
It's like having a perfectly organized closet, everything is in its place, and there's a sense of peace and order.
So atoms are basically neat freaks.
They like things a certain way.
They want all their electrons tucked away neatly in their shells.
Yes.
But this whole outer shell thing, can you explain that a little more?
Sure. Imagine electrons orbiting the nucleus in different layers,
Okay.
like the rings of a tree trunk. These layers are called electron shells.
Okay, so the outermost shell is like the bark of the tree.
Exactly. And each shell has a certain capacity for holding electrons. The first shell can hold up to 2 electrons, the second shell can hold up to 8,
All right.
and so on.
So if an atom's outermost shell is full, it's happy and stable.
Yeah,
But if it's missing a few electrons, it's going to be on the lookout for an atom that can share some.
exactly. And that's what drives those electron transfer reactions that we talked about earlier.
Okay, this is all starting to click.
Yeah.
So we've got atoms with their protons, neutrons, and electrons arranged in these neat little shells.
Yes.
And when an atom loses or gains an electron, it becomes a charged ion. A cation if it's positive, and an anion if it's negative.
You got it.
You're making this so easy.
Well, you're a natural at this.
So now that we understand the basics of ions, can we go back to those northern lights and figure out how these tiny charged particles create such a spectacular display?
Absolutely. That's where things get really interesting. Absolutely. That's where things get really interesting.
Great.
So remember how we talked about ions being attracted to opposite charges?
Yeah, they're like looking for their other half.
Exactly. Well, that attraction plays a big role in this dazzling phenomenon.
Okay, so it's like a cosmic dance floor up there
Wait,
with positive and negative ions swirling around.
kind of, yeah. Now, high above Earth, we have this protective layer
Uh-huh.
called the magnetosphere,
Okay, I've heard of that.
which is basically Earth's magnetic field.
Right, it's like a giant shield protecting us from harmful radiation
Exactly.
from the sun, right?
Yes, but here's where it gets really interesting.
Okay.
When charged particles from the sun, mostly in the form of ions,
Okay.
come streaming toward Earth, they collide with our magnetosphere.
So we've got these sun ions, like crashing into Earth's magnetic field.
Yes.
What happens next?
Well, because these ions are charged particles, they get caught up in Earth's magnetic field lines
Okay.
and are directed towards the poles,
Okay.
the North Pole and the South Pole.
So Earth's magnetic field is like a funnel,
Yeah,
guiding those sun ions toward the poles.
that's a great analogy. Now, when those high-energy ions from the sun smash into atoms in Earth's upper atmosphere, they transfer some of their energy to those atoms.
Okay, and what happens when an atom gets all energized like that?
It releases that energy as light.
Oh.
And that, my friend, is what creates the stunning display of the northern lights,
Oh, wow.
or Aurora Borealis in the north and Aurora Australis in the south.
So those shimmering lights are basically the result of excited atoms
Yes,
releasing energy
Uh-huh.
after being bombarded by ions from the sun.
precisely. It's like a celestial fireworks show,
Wow.
orchestrated by the interaction of ions and magnetic fields.
That's incredible.
Hmm.
So who knew that tiny little ions could be responsible for something so grand
I know.
and awe-inspiring? But, you know, we've been talking a lot about the sky.
Yeah.
What about, like, here on Earth?
Yeah.
Do ions play any important roles down here?
Oh, absolutely.
That's
In
right.
fact, ions are essential for life as we know it.
Really?
Yeah.
Okay, tell me more.
For instance, have you ever heard of electrolytes?
Yeah. Aren't those the things in sports drinks
Exactly.
that, like, help you stay hydrated?
Yes. Well, electrolytes are essentially substances that release ions when they dissolve in water.
Okay.
And those ions play crucial roles in all sorts of bodily functions.
Like what?
Well, for starters, they help regulate nerve impulses,
Okay.
which allow your brain to communicate with the rest of your body.
It's like every time I think about moving my arm,
Huh?
it's ions that are carrying those signals
Yes,
from my brain to my muscles.
that's right. Ions are also crucial for muscle contractions, allowing your muscles to move.
Wow. So basically, without ions, we wouldn't be able to think
Yeah,
or move or even function properly.
pretty much.
Wow.
And that's just scratching the surface.
Yeah.
Ions are involved in everything from maintaining fluid balance in our cells to helping our blood clot.
Okay, so I'm starting to see that ions are a pretty big deal.
They are.
But you know what? I'm still a little confused about how ions are formed through electron transfer.
Okay.
Can we go back to that example you started earlier?
Of course. Remember we were talking about two atoms, one with an extra electron and one that needed an electron.
Yeah, I remember. It was like they were going to make a trade.
Right. Well, let's take the classic example of sodium and chlorine.
Okay, I know those elements.
Perfect. Sodium has one lone electron in its outermost shell,
Okay.
while chlorine has 7.
Oh,
Now remember how atoms crave stability.
yeah, like having a perfectly organized closet.
Exactly. And a full outer shell means ultimate stability.
Yes.
So sodium, being the generous atom it is, decides to donate its extra electron to chlorine.
So sodium's like, hey, chlorine, I've got this extra electron I don't really need, want it.
You could say that. And chlorine, being in dire need of one more electron,
Right.
gladly accepts.
Oh.
So now, sodium, having lost an electron, becomes what?
It becomes.
It becomes a positively charged sodium ion,
Okay.
written as Na plus,
Nah, plus A.
because it lost a negative charge,
Right.
so it became more positive overall.
Right.
You got it. And chlorine, having gained that electron, becomes a negatively charged chloride ion.
Okay.
Cl.
Cl. Okay, that makes sense. So they both got what they wanted.
Yes.
A full outer shell, and they became ions in the process.
Precisely. And as a bonus, they're now attracted to each other.
Right.
Because of their opposite charges, forming
Yes.
a strong bond.
But what do we call that magical bond between sodium and chlorine?
We call it an ionic bond,
Okay.
and the compound they form.
Wait, don't tell me.
Yes.
Table salt.
You nailed it. That's right. The sodium chloride you sprinkle on your food
Right.
is actually a crystal lattice of countless sodium and chloride ions,
That's mind-blowing.
all bound together by their electrostatic attraction.
So the simple act of adding salt to my food is actually a testament to the power of ions.
It really is. And that's just one example of how ions shape our world.
Wow.
From the food we eat to the technology we use, ions are silently at work everywhere.
Okay, I'm starting to see ions in a whole new light. They're not just these abstract concepts in a textbook.
Exactly.
They're like the building blocks of so much of our world.
Exactly. And the more we learn about them, the more we realize how fascinating and essential they truly are.
I couldn't agree more. Now, I know we've covered a lot of ground today,
We have.
from the northern lights to the salt on our table.
Well, a lot of ground.
But before we wrap things up,
Yeah.
I want to make sure our listeners are feeling confident
Uh-huh.
about the basics of ions.
Okay.
All right, imagine you're back in Miss Williamson's chemistry class, and she asked you to explain the difference between a cation and an anion.
Okay.
What'd you say?
That's a great question to test our understanding.
Right.
Take a moment to think about it,
Yeah, our listeners.
and we'll be right back to break it down.
All right, Gem Talkers, welcome back.
Back again.
So before we went to that incredibly short break,
Yes.
we left you with a little pop quiz.
We did.
We asked you to think about
Mhm.
the key difference between a cation and an anion.
Yeah.
Those tiny charged particles that are
Just tiny little guys.
making the world go round
Yeah, keeping things interesting.
as we speak.
Uh-huh.
So let's break it down. Remember, it all comes back to electrons.
Yes.
A cation is an atom that's lost one or more electrons,
That's right.
which means it now has
More protons.
more protons than electrons,
Uh-huh.
giving it a positive charge overall.
Yeah, just a little plus sign.
So it's like a tiny little plus sign zipping around.
That's a great way to think about it.
Now, what about anions?
Anions. Okay, so an anion is an atom that's gained one or more electrons.
So now it has more electrons than protons,
Right.
giving it a negative charge.
You got it? A tiny little minus sign.
Okay, I think I've got it.
I think you do.
Cations are positive because they've lost electrons,
Yeah,
and anions are negative because they've gained electrons.
that's perfect. You've mastered the fundamentals of ions.
See, chemistry isn't so intimidating after all.
I know, right?
Once you break it down, it's actually pretty fascinating.
And ions are a perfect example.
Hmm.
These tiny particles are responsible for so much of the beauty and wonder we see in the world around us.
From the shimmering northern lights to the
Yes.
simple act of tasting salt.
I love that example.
Ions are like the unsung heroes of chemistry.
They really are. And I hope this deep dive has sparked your curiosity to learn even more about the amazing world of ions and the incredible ways they shape our universe.
I second that. And a special shout out to Ms. Williamson's class. Keep exploring the wonders of chemistry. Who knows? Maybe one of you will make the next big discovery about ions.
That's right, the next big thing. Until next time, keep those electrons buzzing, and remember, chemistry is everywhere.
That's a wrap on another episode of Chem Talk. Thanks for tuning in, everyone.